Welcome everyone to another live stream. Linux here, what is more open than open sources doing this stuff. Big Brother style live on YouTube. Welcome here to the Big Brother Linux channel and stuff. Of course I couldn't resist continue last night and got more of this Rust cargo cross-compiling stuff under control, which is certainly amazing. I think I'm like 99% through of integrating, configuring, scripting all the stuff to cross-compile Firefox. It works for most of the part. However, as you see with all the videos, it was a large feat. Actually, did I say? All right, I think I said in a previous video this is the last Firefox cross-compile video. However, that probably meant a pure old version without Rust and cargo. Due to the nature of this bootstrapping process, which is rather complex, of also requiring a C compiler and C library, and it doesn't fit exactly in our stage 0 toolchain, stage 1 cross-compile stuff. I will later in another afternoon or so need to rewrite some of the stage handling of stages of bootstrapping T2 Linux. So yeah, for Rust and cargo 20 years later we need to rearrange our bootstrapping stages so that currently 0 is toolchain, like cross toolchain, cross compiler. Stage 1 is cross-compiling all the stuff, and 2 is native. So basically the rest is mostly stage. The rest is somewhat unused. It's mostly like 2. The rest is all native compilation, which, fun fact for the cross-compilation, we anyway don't use. It's like more like 2 is like just rebuild some stuff like GCC to be safe, and then stage 5 is build all the native stuff. And yeah, so certainly 7 of 9 stages. 7 is somewhat unused. Anyway, so what I need to do another day, which not today, so right now I need to YOLO that a little bit in terms of like first build the C library and then continue with Rust until there's only so much you can do in one day and night and stuff. We have some other small things to improve though. But yeah, also for Rust and cargo 20 years later, the biggest major rearrangements of stuff. There are some complications though. One is also, yeah, new infrastructure stuff, new compiler stuff. And this is to be expected, collides and needs extra guidance with some of our tricks, like defaulting to 32-bit for PowerPC, but certainly also aarch64. So the precious P3 PowerPC 64 32-bit default does not just build, I guess, because also, yeah, how much stuff, I said this before, how much stuff do you need? I think configuration and arguments out of alignment for GCC and Clang and Rust to 32 versus 64. For this reason, as you see, not here, but here, I now build a classic regular, like how I've done it for decades before the PS3, pure 64-bit, where stuff is 64-bit by default, just to see. I mostly want to see if this bloody stuff after all this work actually freaking works. One other note, so we will also continue with some ARM optimization. So live here with this channel, and you share, like, and subscribe, and watching this, you support all this excessive work of configuring and documenting all this stuff. I'm also building here already 32-bit x86 as I want this on my Sony Vaio P here, because there's never enough of testing enough. And one last thing you have seen in the previous videos, that this Rust bootstrap stuff was bloody slow, like ridiculously, hilariously slow. And I have to take this somewhat back, because so bootstrapping Rust took 48 minutes or something as crazy as that, or 42. Depending on, and just last night, because I was like, and some of the Rust compilation unit processes took like 12 minutes or something, and I take this a tiny little bit. Rust is only half as slow. This was also, can I spin up without getting stuff? Not even sure with my I patched this already last night. This was our smart optimization that I rediscovered previous video of optimizing smarter. And so actually it turned out that this was only due to LLVM not being optimized. So with the smart optimization, I thought we optimize our default ISOs little bit better. Smart is basically our own profile-guided, database-driven optimization of building everything size, because most code never runs, or like startup code and stuff, and argument parsing. And so yeah, even if you load like Firefox or GCC, like certainly probably 90% or something of the code is never run and just sits in the cache or is not even read from disk and stuff. So anyway, so in some infinite wisdom, this was not wired up for a system compiler wrapping here, though I'm not sure what we were thinking there in 2005. Also, yeah, 2020, 15 years later, you fix some smart optimization bootstrapping stuff. The good news is with this bootstrapping, Rust and Cargo is significant, Rust mostly, Rust is significantly faster. And so because Rust is using LLVM, this is also the whole Firefox process of that, of compiling Firefox with LLVM being so, yeah. Another thing, so you would think, yeah, with all these days of work, this would finally work, but unfortunately not. Let's check here some Firefox ARM, because not only building PowerOS A64 and 32-bit x86, but also ARM64, and there's always something, right? So, I mean, this is also, you made so much progress, you're not 99% done, or I hope I still, after all this work and late night shift and stuff, I've not yet cross-compiled Firefox. Oh, and by the way, yesterday's video on the More Life channel with Rust, the latest Rust failing, compiling Firefox with their macro hygiene stuff there. I think I'm like, because I thought then, okay, maybe my system Rust broke with all the random breakage, but I had exactly the same error of Rust macro stuff not parsing there and expecting tokens where there were others. With a cross build, so this like a pure clean bootstrap of, so I guess after all the latest Rust version 147 or so, I guess isn't compatible with Firefox, because I think so. I downloaded this locally. You can also Rust C version. Also, this was a typo. Yeah, 140, so it's 147 to 146. I downloaded this locally again, because you can never test enough. And now, lo and behold, this ARM Firefox stuff builds further. So I'm not pretty convinced. So probably something is like a little bit fishy of compiling Rust into the system of previous and new versions. There's some strange stuff happening. But with a fresh bootstrap, I kind of double confirmed now that this latest Rust doesn't support this. The next thing is, so the next error, so because I'm now 12 minutes off, yeah, how long does this stuff build? Like, yeah, 12 minutes. And this is now with optimization, obviously, right? And now I have the next error. You can never have too many build errors. It's kind of never-ending story, and as you see somehow my life, documenting this here on YouTube. And so the next error is AES ARM version 8 compiler option is invalid. And actually I had some other thing also of not inlining, but do I have, let's maybe, or did I, wait a second, where did I look? Oh no, I looked into this, probably error option is in, did I only get this one, or thought if there another one. Anyway, so this is related to ARM inline assembly stuff. So this is also what I wanted to debug now. So up next, like now, documenting and yeah, thanking you for tuning in and watching this channel and spreading the word and hopefully learning something of all the details of software development. And I swear, after finishing the next ISO release circle here of having minimal Firefox for you, playing along at home on the PS3 and SG Octane and so on, I really will continue with my own JIT infrastructure stuff and microkernel, because after 20 years, it's time to move on a little bit more development and research. Anyway, so what we also will do now is, so the reason I think this doesn't, also on my terminal, Tmax is here. So this doesn't build because I think I VI'd this file already. So this is compiler option invalid. This is ARM feature. So I think there are probably two things at play here, and I wanted to use the chance, as always you discover something. Where would this even be? GCM was it? Because I already YOLO'd here with pragmas in that file. Let's see. Because we have two things here. One thing which I've already hidden with messing around is that neon somehow doesn't inline with this assembly or C language in strings, and not really sure if that went away with O2, but actually I think it didn't. But I said another video when people ask, or maybe this was just a comment the other day on YouTube here on all your amazing comments and people who notice typos. I said in that comment, yeah, because the question was how do we optimize for ARM64 with all the different SOCs and CPUs, and I actually said like, yeah, for ARM64 it's not that difficult because we do not have too many instruction set architecture variations yet, in contrast to ARM, where we had as many as x86, like I think 386, 486, we had all the ARM, Cortex, whatever, and then floating point, old-fashioned version 3 or whatever, this is thumb, compressed thumb or not, and single instruction, multiple data, and all the other stuff. And I stand somewhat corrected. I probably next can integrate this here, so these are all the variants to so much. I thought, hey, ARM64 is so new, we probably like only have ARM64, but yeah, also, yeah, the recurring theme of ARM also don't find this at Intel and AMD. At least you have like somewhat usable names, but here you have ARM version 8, and then it's also like CRC. So these are previous video instruction set stuff. This is logic gates in your CPU implementing instructions of cycle redundancy checking, CRC, and floating point 16 whatever dot product. This is this bin float 16 or so, and whatever IAMMS, no idea. Anyway, so we have already more than I thought. I thought like we have like ARM version 8 something, but yeah, we have already 1 to 6, and although some might not even add new instructions, whatever sort. So we probably, so this is Arch, so we have march and CPU, and I slightly wonder, so we have CPU name, specify name, target processor optionally suffixed by one of the features, so we probably want to add them, so this will also be Cortex something. I'm somewhat, the problem is for ARM32, we have a lot of this list copied there to our optimization options. I'm not, so the question is, with this ARM socks, people also often don't really quite know what they got there and what is ARM version 8, because this numbering, I mean, who wants to remember for a decade or two to come in which 8 point whatever they added whatever, and maybe they added nothing. So either we copy this, I have the impression probably they don't support MCPU. Do they support this architecture? We can actually test this with having, so what the issue is that it's trying, so where's even char? Is this not a various crypto LSE? Which of those is even crypto? Yeah. Anyway, we have already some comments and some people tuning in. So yeah, welcome everyone, people enjoying that. Automatic M4, something toolchain, slightly curious automate need, something whatever. That was how they fixed that thread from yesterday. I had read that it won't, not sure, whatever. Something with the proc macros failing in 147. And from default I saw something, not sure, something. So welcome there, Jetson. So seeing the Jetson selling in a budget model for under 60, please. This is the same architecture. Not sure what exactly the NVIDIA Jetson is, so I probably need to clean the, oops, marked this wrong. How did I actually need to close this door was not, balcony door was not the most closed there. Let here some fresh air in because fresh air. But also I don't want to freeze because autumn. So yeah, welcome everyone. Low cost version. So we are compiling here, which is good. So what I think is going on here is, well, this might be partially caused with our wrapper stuff, removing stuff. So we are removing all this aarch64 stuff because we want when the user or developer configures T2 to optimize for Core I or Zen 2 or so, then that's what they're supposed to get and not the package behind the back automatically in the background, because nowadays nobody wants to mess with TOML, Meson, and who knows what Python build scripts files. So this is why we remove this automatically. So maybe they build this file and then have some feature detection. But what is also curious, so there was also another, I wonder which one, where's the GCM aarch? There was also this inlining stuff. GCM, was it this? Oh, it should have been this. So we somehow need to fix this. And also maybe for, cling failed with, what did this fail? Build target, poor PC, no. So much to multitasking of, oh, wait a second, this is one cling. Okay, one cling we actually don't need the most. This is already, then we can also need to, yeah, we also, this is the stage rework stuff that I was talking about. Let's comment this out for a second now that we are so far in the build and rebuild the Rust. That probably this is, yeah, for now testing YOLO, and otherwise, darn. Shouldn't press Ctrl+C there in the configuration. It can at times mess up that, but maybe it didn't. So let's test this Rust-C for PowerPC because I'm curious to see yeah, if this works. While we are, it's always good to have two things to test because ARM64 with the Neon optimization fails differently. Let's see, I'm not sure if, where do we have our, here. So let's touch test C, no, that doesn't matter. Let's GCC wrapper bypass for a second so that we don't translate their stuff. aarch64 with mCPU equals that. I have the feeling this might not work, but let's see. Test C. So yeah, that does not work. So the issue is that in my opinion, these are a little bit many cores. This is ARM continues to make somewhat the same mistake as they did in the 2000s of too many strange names, renaming version versus ARM number versus ARM version number. And I wish they would have this a little bit more feature set like x86, although certainly this is also a cluster F, but yeah. Okay, so ARM version 8 works. Why does it not find main though? Should this not work? Undefined reference. Undefined array. This is, yeah, so this is what I figured from the options here. So this was just a test. Maybe, well, we could always create extremely many options. Although I'm not the greatest fan of too many options. Maybe I start adding those here that have some instructions by default, because I somewhat don't see quite the point of adding all these cores where all the tiny differences between that, it's like, yeah, leave in the comments below. Somewhat, I think somewhat this should be enough, but this is also why I said in previous videos with like, why still statically compile machine code like that to this kind of fixed instruction set selection when usually, at least on general purpose computers and also somewhat phones and smartphones, like applications, maybe this should be on the fly optimized for single instruction multiple data and not statically precompiled anymore, but yeah. Anyway, so more people tuning in, which is amazing. Nintendo Switch, so yeah, maybe I should have. Actually, when they hacked the Linux install stuff on the Nintendo Switch, I was thinking to get this for this channel. Maybe I should have. Maybe I should still. So yeah, PowerPC. So this is, I think, so let's double check this. Also, let's clean some random stuff here. Of source PowerPC. Oh, Rust. Do we have two here? Okay, this is still cleaning. Should probably be that one of just checking that our, not that we wait here 10 minutes and then our Tom's obviously minimal toml config is Rust of config, or let's check X, or actually we could check both. So X, okay, this is correct. And this is included in config toml for target PowerPC. And yeah, that's in there, that has a chance to work. Let's better hope it does work. And then let's see. But you see it's way faster today and obviously amazing. So for this to work, for Firefox, what did we even, let's build that again. So I think, yeah, if it wouldn't be so this random build stuff of like it's trying some assembly stuff and inline stuff, and so yeah, this is the other inlining fail. I wonder, neon inlining fail. Maybe this is, let's see, did this disappear with, because I wanted to double, oh wait a second, this is the wrong one. I think it's, I added here Pragma, was not entirely sure did this work or not. But I think it disappeared with, let's see if that works or not. Inlining call to always inline neon in, is that another file or GCM? So this did not work. What kind of, so we could actually, so the problem is also that you don't see what, with this modern build systems, I mentioned this already earlier, I slightly wonder how to verbose build. Is it v equals 1 or? Because the annoying thing is I don't even see recurring theme of constructive critique. Also, why do they hide this? I mean, this build output stuff is only for developers, and then when developer need to see what actually is happening there, you don't see this. And then you always need to fiddle around on a per project basis how to re-enable verbose build. Also, how many warning could this be? Warning annotate direct what? Yeah, so many warnings you don't even see. Let's see, reverse search for, do we see here GCC or neon in, let's maybe reverse search for that and see if we search up for that. Error. There's also another error. Do we see the maybe we should, yeah, but also, I mean, between all the pointers warnings, you don't even see at all what's happening there. Maybe we go in here and see if we find something neon of, would this be, here's something maybe, so MFPU, so also, yeah, can never have too many build infrastructure stuff of Gypsy stuff here. And it's, as you see, messing around here with this stuff. So I wonder whether for this to work, I hope they have CPU detection, because this most likely Yeah, but recurring theme, modern build systems and packages, tricking, yeah, for optimizing the heck out of this, tricking around with the build process and breaking stuff in ways you don't even can easily debug. Here it has here ARM Neon supports and software stuff, so it looks like they have CPU enablement. So what we, but so ARM, so what would this be? This would be, do we even have FM? Do we remove, let's see. So to work around this reliably would probably disabling the removal. So we have here mtune, march, and this is mfpu. mfpu, I think we don't even remove necessarily. We only remove here mcpu and stuff. So by the way, what I really don't stand in this BSD tools also as inherited by macOS. In macOS you can't type it like this, and macOS it will complain that it didn't have a password. In macOS you need to type this dot due to the inheritance of BSD tools. Not sure if that's probably the same on NetFree and OpenBSD, but in my opinion it's somewhat annoying, this kind of old-fashioned stuff. So this is targets Intel, also conditions, CC is cling, integrated as. So this is doing here a lot of. So I mean we don't remove that though. Where's our ARM or aarch? I slightly wonder. Oh, here's do we remove march? Maybe we remove march, huh? Arch we remove, yeah. I mean, for a test we could var append gcc wrapper remove from remove and march. Somehow this didn't. Oh, not append. And build that just as a quick test. That might not yet fix all. But yeah, this other kind of breakage. You automate all the stuff of nicely optimizing this, and this stuff is fighting optimization. So what else do we have? So yeah, some people tuning in. Dev service, version number of changing things. What I think most problems dev have is in version number of changes for things that make it, break it. Experience and yeah. So I mean, with Rust, they basically, or are we even freaking compiling further without an error yet? I mean, it's not ideal that the packages behind the back of the build system of T2 Linux distribution build system fiddle around the stuff, but it's like, yeah, it should have CPU detection. Maybe notice if it's segmentation faults then later on. But what else did I wanted to say? It's for quick workarounds is maybe I just commit this anyway before we. Another solution would be to selectively on some files, like if like change this remove it everywhere except this single instruction multiple data files. But for now, actually, this is still compiling, I think. Surprisingly, previously, so before I went live, I still had, like, I removed other stuff, and then I had, like, linking error of the CRC symbols not being in there. So, but actually, maybe this is an issue of if defing, like if def defined and not compiling with arch something that maybe. Anyway, so also yeah, I found the actual sensor chip for this grep just, yeah, nicely turbo boosting for this Rust code, apparently what is it? Probably Rust. So this is now with more opti-pivot fabricate, LTO. Yeah, you get the idea why stuff is building here forever. So nice progress. So probably while at it, we are waiting now for these builds. And I also need to cut this here a little bit short in terms of what we publish. This PowerPC 32-bit is relatively new, and given that I rather of like saving cache and memory, especially on the memory limited PS3, previous videos. But to be honest, I have no time. I have way too much other. I already stress quite some other stuff that I actually should do, obviously, to build this channel and get more open stuff going. Obviously, also there's Patreon if you want to support all this feeds. But what I want to say is I will cut this PowerPC 64 32-bit default ISO short a little bit because I simply have no time to look into configuring Clang and Rust so that this would work. If this works for PowerPC 64-bit binaries, this is what I will ship for now, and then we just use a little bit more cache and memory again, YOLO, whatever. And you can certainly, like Danny, build this at home, and we have larger things to do, like proof of concept research stuff of maybe jitting everything, of only having dynamic code and think sort of Java just on steroids and smaller and cooler and without Java API, because certainly don't want to get sued by Oracle. So yeah, so much turbo boost, and probably I need to thermal repaste this. So what I wanted actually to do also, hey, Rust built here for PowerPC. So how long does it build now, being more optimized, and we built in only 8 plus 6, so 14.5 minutes of, that certainly is way better than less optimized. Certainly I can cut this probably as if we update our profile guided smart optimization database for LVM, Clang and GCC. We probably could probably also, okay, Clang, let's touch here, Clang native build. I don't need, is this even whatever failed there? Not interested in that. I'm only interested in whether Firefox cross compiles after all these efforts. But I mean, it looks like we're on a good path here, unless we hit the next crazy thing. Certainly we make some, is this even the right? Probably should be the ARM64. So while we wait for this build, so the PowerPC build is freshly started from scratch, as you see, for maximum testing, obviously. This builds all the Xorg and Mesa stuff, so this will take some 30 minutes on this Epic Thread Gripping AMD Ryzen 3950X overkill build. And while we are at it, we can type in here our ARM optimization stuff, ARM64. So for ARM, we have here quite some excessive list, starting with all the vintage cores. And somehow, yeah, leave me in the comments. I mean, this is autofan. This is crazier than Core and AMD stuff. It's somehow for me mostly. I mean, tuning like instruction units, ALUs, and so on. I mean, somewhat this is stupid. The only thing, I mean, also like for 1-2% difference of between ARM 940T of and I think for ARM64, I'm somewhat tempted to only have here more like the list I've shown you here a second ago. Also, where is even our Firefox? Now this failed, of course, with something svgl set undefined reference to set texture buffer. Why would that be? Yeah, you think you're finally 99% done, and then, yeah. This is also why a third party actually dwarf mangled line number section, but file number of what mangled? What? Yeah, segmentation fault of what? Flist wrapper, maybe something randomly breaking there. We could, maybe this is some file somehow mangled with whatever. We could try this clean. So what we did here was var, also wherever this was var, remove. So let's, at least for ARM, like try a fresh build, because there's never something of whatever you ruin there in the middle of random rebuilds, or maybe our own flist wrapper crashing. Where is ARM? Do we have already some ARM? So actually the question is, with this elf hack, actually, you know what? Oh, wait a second. We don't disable the elf hack for ARM64, so let's do that here so that we have platform-specific stuff, not removing this aarch for all architectures, and do a clean ARM64. This probably should build Firefox and not cargo. That failed anyway. Probably we need some, yeah, all the configuration details. What we need there is like a native cargo. Means so far it's using my system's cargo of, yeah. Also, wait a second, we don't really need, don't wanna waste time here of newly added stuff. We only want Firefox. Firefox, there we go. So yeah, in my opinion, let me know what you think. I think this kind of stuff is way more than enough. And this is also the benefit. I mean, I really wonder, this is also why I want to move to more interesting stuff and not this like sitting here and building others people vintage code. Like JIT, I really wonder, like think Lua JIT outperformed some tightly optimized C code with single instruction, multiple data optimizing Lua, and I really wonder if you build like a smarter than Java, or certainly Java was not, well, in the beginning, who remembers that Java in version 0.1 in 1994, 5 or something, didn't even have the JIT compiler. I really wonder if it would not be more worthwhile to just JIT all this stuff and let like sync transmitter code morphing. Although somehow maybe but this is also the risk of development and research. You think, could this not be more amazing? And some people like Java and transmitter code morphing, previous video, of course, were not the most amazing, but I really wonder if it could not be somehow made more amazing in terms of a really lightweight, certainly, yeah, QEMU TCG, LLVM, although LLVM and QEMU TCG, if not Java, somehow proves that dynamic code compilation often somehow is not faster. But nonetheless, it's also not the most scalable. I mean, certainly Android is doing it a little bit with ahead of time compilation, installed packages with each system update and installation optimizing this. But maybe this is also, you know, installation time, maybe this would still be similar to what Google is doing there on ahead of time optimization at install time. Would this not be more amazing in terms of Linux distribution of like not Gentoo NT2 emerging this for your local CPU with all the variants, and then maybe your system breaks or you go home and don't have an epic thread-ripping Ryzen there, and you plug your SSD in there and it doesn't boot because over-optimization of latest and greatest AVX2 or something, somehow this on-the-fly optimization for you with all the AVX 512 and whatnot features. And also what I said before, right? Previous AVX 512 sucks a little bit, just like Linus Torvalds said. you need to optimize for it, and otherwise you don't use it, and somewhat quite wasteful there, but yeah. So I'm somewhat, as I said, is this not enough? Because otherwise generic, so we have here ARM8, and then what is FP even? ARM version 8, what does it, what exactly should this be? ARM v8, is it A? Where is a list of all this stuff? I mean, we could, A is ARM holdings A0, A what big out of order execute. Simultaneous. Yeah, we could also look in the GCC sources as we've done for previous video. So I would also even document this here, but I mean, seriously, with all this cores and over optimization and do we even start with, also probably I closed this, didn't I? So first would be A, so this probably dash A is already adding something. What do they have here? Plus SIM, plus SIM, plus FP. Maybe its best reliable source might be actually to look into the GCC sources. There, at least you see what you get. So yeah, I would also document this here so that ARM v8, I need to be slightly, what do we optimize for here? I hope I have this at generic. ARM, now we have, wait a second, optimize, yeah, generic, so that that is certainly without any other extensions. Also we could probably certainly name this generic ARM ARM v8 also. So this looks somehow alien, ARM v8. So that becomes, so it's like 7. So what have I done there now? Because otherwise, as I said, who wants to select the precise core and then you don't know what you get? So how many could this be? 5. Do we not have something? I've somewhat wonder if it even makes sense to, did I not leave? Whether, did I not, maybe I didn't copy this. I mean, is this immediate 8 or what is it? I8, what should that even stand for? The feature here is, by the way, ARM feature. So CRC, obviously this is the default for ARM. Crypto FP enables floating point instructions. This is by default for all possible values of. This is on by default for all possible values for options aarch. But why do they write in there plus FP? This is irritating. Single instruction. I mean, this is obviously well enhanced, also enables floating point instruction, default for all possible values. I mean, yeah, so I mean, it enables, but is the default for all possible values is like, nah, somehow. As amazing as the PowerPC stuff, the other video. to copy this. So so if this is the default, I wonder, so I mean, okay, CRC, so yeah, then this somehow is the default, although, nah, so we probably don't really need that, I would say. And last but not least, also, I think I didn't. Why is this here even, by the way? Save here ARM version 8.4, ARM version. Ah, okay, so this, I mean, okay, they reference the previous, although here they have it capital and they're not. So that would be like plus CRC LSE, that people have an idea what, oops, ah shit, RDMA, whatever that is. And I probably want to make that. So yeah, those who, I mean, this probably only like internal improvements of speculation and whatnot. Not really sure if it's that much worse to include them. Maybe not. And so where would be, I mean, some of the stuff is, I mean, obviously, except that it's enabled by default. Scalable vector instructions. LSE, so it's large system extension instruction. What? Large system extension instruction. What even should that be? RDMA is, so it's not DMA for direct memory access, but round, double, multiply, accumulate. Okay, so I would have rather, I mean, maybe that is their internal name, but this name is also slightly stupid, of sounding like reverse DMA or something. Why is it? Maybe they should have named that RDMAC for multiply and accumulate or so. And, yeah. So this is FP floating point 16, as we see at others. And what is that? RCPC, code generation from parsers to send enable inline and stop instruction with RCPC extension. Nah. Dot product, I mean, obviously AES is AES, char, did we even, so we didn't even have this char stuff in here, right? So even those do not include, but yeah, I mean, the compiler, this instruction is also not something that your C++ was compiler easily generate, because, I mean, it's not the easiest thing to detect of this huge chunk of code is char or AES algorithm. So yeah, this kind of stuff is like, yeah, it's assembly in strings and nothing else. So yeah, but given this, I mean, it's like maybe nothing. So this is only scheduling of, at least I guess it's scheduling. Theoretically, leave me the comments below if you want that I unpack GCC and take a closer look. And what else? Crypto extension of, actually there are quite some more that are, and BF16 for brain half? What? Not, I thought this is bin and not brain half precision. I thought B stands for, does Intel also call this Intel BF16? Don't tell me they call this brain. Is this not B float 16 of, do they call this brain? Apparently not on the first glance, so. Oh no, brain float, you can't make this stuff up. Deep learning research, what? Why does brain to Google Brain? What the heck? B float for brain floating point after Google Brain, okay. The more we do here live on this channel, the more we learn here. So in case you were wondering, we fact check here most stuff, if not everything, and even I learned something new. I thought this is like binary float something, so could never come to my idea that this is brain for freaking neural network stuff. Anyway, so I hope I did even not mess this up. No, it looks like I didn't mess that up. So this is like documenting what it is adding over the previous. In my opinion, I don't need to over-specify this here. I have a similar, not identical, but similar for x86, which maybe we also want to revise on some other day, because somehow all these optimization options might be somewhat out of control. But maybe something of that sort, and then I check the comments where we wait for this to build. By the way, did I noticed the other day ABI. Yeah, we don't have this ABI here anymore, right? So this is actually, yeah, but whatever. This changes our, because I noticed the other day we have here a double digit in, after I clean this up, we have here --4. It's also a tiny little bug of previous commit. Also, by the way, just today I accidentally realized the other day when we cleaned this up, Samir asks, is T2 like build root? Yes, build root on steroids and 20 years in the making, in my opinion, of all the projects that loaded superfluous. T2 created in 1996-ish in form of Rock Linux, which I participated back in that day, and nowadays is known as T2, for try to of making this technology 2 more amazing. On top of build root and other stuff, 3,000 of packages and including Rust and Cargo and stuff. Could go faster if files in memory. Yeah, we have temp as usually. If you mean that, AC of matrix could go faster if files in memory. Yes, of course. Usually I built in tempfs. There is an option for that, and just for debugging I need to disable this. Otherwise, I lose sources, and I don't want to rebuild there in 16 minutes time. Okay, while I don't like a space at the semicolon there. Just anyway, so generic ARM, maybe we ARM v8 that or so, and then only those who make there a change. So yeah, this stuff is building. So yeah, with PowerPC we are awaiting. Well, this takes a while, as per usual, especially as fully loaded as we are, with 2 builds. But yeah, don't forget to like and subscribe for testing Zen 3 Threadripper. So it's planning what I'm upgrading to this as soon as it's available and stuff. So yeah, if you want to see Zen 3 Threadripper on Linux, then don't forget to share, like and subscribe. Spam train Z. There's also some emails of only garbage. So it's 2 emails in 2020. T2 updates. So we got here some update, and previously we have a bot for that, and soon I put this into production, because this obviously don't want to manual paste it anymore. GDM, so not more stuff. We could check if there's already the first point release of the Linux kernel to update that, but I have the feeling probably not. 5.8 no. But there is 5.8, so theoretically never enough of out of bounds in case by out of bounds in your network stack BPF bounds also revert, obviously revert, and oops of dereference, how to check quickly for security vulnerabilities in your latest Linux kernel. I prepared here the other day but we wait for the first point release. So this is what we need to revert set standard patch and lean. Oh, we can. Oh no, we can't. That's Linux desk of always something to do while we wait for that. So 8.15. Let's download checksum patch that. So yeah, we are pretty close. Alex asks, do I use Ccache? But yeah, thanks for asking. I answered this already a couple of times, but yeah, new people, new subscriber, which is amazing. Thanks for joining. 15 years ago I did. The problem is nowadays, not only Rust and so on, and then given due to the nature of the whole distribution build here, the cache is quickly invalidated. For example, you update some glibc or libx11 header and most invalidates, or a lot of this stuff. For example, PowerPC previous video we fixed GCC, latest GCC sends this patch upstream, which, fun fact, maybe I should check if GCC Bugzilla, but I didn't got an email. Maybe I should ping there some people, because watching, sharing, like and subscribing this channel, you support open source work, and there's also Patreon in the links below. And this Bugzilla, where is your login to? Let's see, maybe we are still logged in if we are lucky from the other video. Fixing like G5 and cell, does it maybe find our bug? Didn't hear something big, and maybe it's this one. And yeah, like if we fix something on the low level like compiler, glibc, Rust and so on, then usually the cache invalidates completely anyway, or yeah, should actually, fun fact, by default Ccache timestamps the compiler executable, and I patched this away probably because with T2 each time you bootstrap a new compiler for the Ccache to actually have any sense, we can't bootstrap the compiler, and is there no patch anymore? Interesting. But whatever, I thought we had a patch for that, but maybe. Long story short, 15 years ago when cross-compile support in T2 was not as advanced, and I natively built on my aging 270 MHz UltraSpark and PowerPC hardware and stuff, I used it, but depending on what I did, like a new GCC version, like .1 point release, and everything is invalidated. New Linux header, ABI stuff, and nearly everything is invalidated and stuff. So for this kind of infrastructure, like adding new ARM stuff, or like ARM optimization thing, we built a little bit more optimized, or this Firefox stuff, building what I just changed here with removing the aarch removal, and all the files affected there invalidate anyway, and not to mention like Ccache is only for C, and now we have the biggest compile time stuff in Firefox is Rust anyway. So if 25 of the compile time, so unless someone writes a Rust cache, maybe is there, I'm not sure, maybe there should be theoretically. But by the way, so this is our bug, PowerPC cell optimized. So yeah, so much to nobody is taking a look at G5 and cell love. Welcome the Graver, which also Rust cache or C. Rust cache structure easy, build cache culture, whatever else. Yeah. Target, maybe there is some Rustlang build cache, maybe is this integrated of cargo stores the output, target direction. I mean, yeah, probably I'm not entirely sure whether somehow have the feeling it doesn't cache much. Apparently there is some caching, but yeah. Anyway, so let's see, the Graver joined. Speaking of vulnerabilities, OpenSSL-T2 went out of life in December 2019 as non-secure vulnerabilities code flaw found. Yeah, probably. I mean, so the problem is, maybe you said this, but probably this, as you mentioned this already. And yeah, okay, not wasting CPU cycles of updating this. So yeah, let's commit that. That looks good. Yeah, thanks for that. But I wish they also wouldn't they changed the ABI, and the last time I checked, a lot of stuff didn't build. But probably with non-vulnerabilities, it's time to finally also zero frames open SSL. But yeah, if you run a distribution, there's also old 102. I mean, theoretically, we have LibreSSL, but it's like, yeah, I mean, they theoretically also had vulnerabilities, right? The problem is OpenSSL 11H, is it 11H? 2019. I would hope that in the meantime, every package, well, everything except outdated stuff, obviously, did update the ABI. In my opinion, also a little bit of the fail of upstream packages constantly changing the API and ABI. What else do we have here? 11H tar gz OpenSSL1. 111, there's one missing. Yeah, this 10211, I'm pretty sure they changed APIs. I think stuff wasn't building. Why is this still not error something? OpenSSL, FTP. I mean, oh, by the way, do they have, they have, maybe we also use some HTTPS for FTP OpenSSL source. What else is here? 11H tar. Oh, what did I not save this? What have I done now? Ah, here I mangled this with that is much too. But we will see. I'm pretty sure there were ABI changes, but yeah, which is also the reason why LibreSSL is not the default. We have a package, but yeah, this ABI change, man. Yeah, okay. I mean, after a decade or two, some ABI change, but yeah, maybe some compat header. I mean. But let's see if that builds OpenSSL. But yeah, thanks. Patches welcome. Points here also where the patches and hints. Super H. Does someone care about Super H? Whatever. Configure. The thing is, the stuff that I personally didn't touch in a decade or two. It's like, yeah, SVN RMF, and also so much to simply building this, probably not the most. Drop-in replacement. The open has been successfully configured. Pre-make, well, resolve some conflicts. Okay, maybe this was installation. Okay, let's try if we can build without this boilerplate there. I mean, I hope the other configure and build stuff, because this was a little bit exotic of not the most straightforward configure make install. Also some graphics. This is also, yeah, just rebuilds. This is also waste of time of random temp stuff. I need to debug this someday. Usually it goes over a second build. Not sure what happens there with the flist tracking stuff. By the way, maybe I should clear the dmask to better see if we have a new one of Firefox, because not sure if segmentation fault, our own flist wrapper stuff might be crashing there with whatever. This will be painful to debug if that still is the case in production. So looks like the rest of the build system might be as unchanged. Openness and shadow. Why do they touch password though? Theoretically, we can, where's our PowerPC build is here. Let's, because the PowerPC build didn't advance that much, let's not only maybe just commit this, I would say. And let's mark this at least CVE something. Thanks for that. And let's delete all the PowerPC stuff that we, also not 32, that we test this the most. So we should have var ADM depths dependence PCs. Did something use OpenSSL? Maybe not yet, apparently, allegedly. We built it, however, so let's remove that. Let's cross-compile it to PowerPC and see if something OpenSSL in the log. Not the most, only core utils of what? Checking whether OpenSSL is GPL compatible? What the freaking heck, are you kidding me? OpenSSL support not requested for kmod kernel signature verification stuff. Okay, fine, so this is a good test case of, oh, wait a second, maybe really not to have residual files there of PowerPC 64 SSL, just to install it, not otherwise we have the previous files in there and then it could hide some errors with using wrong headers or something. Probably have to recompile the package depending on OpenSSL. Yeah, not caring too much of having the old library in my system right now for rolling release from source random build stuff. It's more like new ISOs, but yeah, good point. We are in the process of spinning new ISOs, so that is certainly welcome of finally making this switch, all the switches 2020 only live on this growing YouTube channel, doing all the work and research and stuff. So OpenSSL, what do we have here? Okay, this was our native build. Whatever. So it also cross-compiled. We will soon see, theoretically we could check less build PowerPC 64 of OpenSSL. Did it correctly? PowerPC something. Yeah, it actually really cross-compiled. Always good to check after major update, but hey, we committed this already anyway, untested. Yeah, so PowerPC 64 there. So if, in case you were wondering how long are we building 13, so this is already 30 minutes building. Where are we with, well, we are using the Epic Threadripping Horizon here a little bit in parallel with other builds. Also util Linux failed because something, what does this want? But just in case you were wondering, util Linux of, what? Maybe some stray glitch of cleaning this off. Maybe this file locking wasn't the most. No, it's not file locking. What the heck is going on there? It could also be sometimes architecture. It could be this is also really stupid shell stuff. No, not here. Maybe parse config. Maybe we need to resort to xtrace, PowerPC config xtrace. It could be that some config command evaluates false and then it builds that. But what is with our Firefox build? Yeah, 27, 26 minutes in here apparently. Probably wouldn't surprise me if, okay, LTO, but actually, wait a second, is this? Did I not have this marked LTO Firefox of, probably it did LTO by itself behind the back of the distribution. It looks like that. Yeah, so here, what is this here? Case something in at stage. So it's probably my theory of altering Arch machine at stage native. So maybe, so this is at stage native, alter Arch, I guess. Yeah, so this is also really stupid. That just the last command of this function and then with trap, like set E for trapping on arrows. This is hilarious. So I mean, basically, I don't even. Yeah, this is really hilarious. This is also like returning like the last like percent question mark return value thing is function return value. Actually, you know what? I think we could, was it arch builds? So at stage, I slightly wonder altering arch to power. Wait a second, this should not. What at stage native or arch builds? Why do we even, or do we, or maybe we built this twice, but probably if we move that there, we can work around this. It's not depending on that, so probably just not having this the last. Yeah, it's stupid, but it's shell stuff in 2020. Or if you know if that is a better. Also, this failed because 33 minutes in. Alex writes LTO's default upstream. That might be, although it maybe it should honor the. So actually, unfortunately, this is also this is not really unfortunate. So this is not like a random build fluke thing here. So this is reproducible exactly. So yeah, this is my life and double checking and testing, and you never knew what broke. But this is unfortunately the same build error we had previously. So much to wasting 30 minutes of precious compile time for double checking that. So this is invalid abstraction. So this is dwarf mangled. So I'm not sure if this is like mangled invalid abstract instance of exceeds maximum. Also, by the way, specified built in memset specified what? Specified bound exceeds maximum object size. String overflow. In case you were wondering, this is code quality of. I somewhat wonder if. So, I mean, yeah, what's going on? No idea. This is also a recurring theme of. So wait a second. This is G crust of Rust code, right? Is this probably Rust generated of, what is it even? Undefined reference to get integer v. So unfortunately, this is Rust code, I think, in RS here. This is SVGL Rust line. Nah. So something, maybe something is wrong with binding generation of, not sure if this, but yeah, the pain of cross-compiling, maybe this bind gen, maybe we need a cross-compiler where it's cbind gen. But yeah, you see, we can now fully build it, like fully cross-compile it, but it just doesn't link there. Might be some other thing, detail broken there in between, unfortunately, which obviously is very sad after all this time and stuff. I probably wait first for the PowerPC build. We could also Google this. So yeah, recurring theme here, debugging all this mix of build system stuff, really complex, because you do not only need to master C, C++, GDB, build system and stuff, but 2020 you Rust, Cargo, cbind gen, Clang, LVM, and everything. If you have an idea what this could be, leave me in the comments below. But yeah, just another testament of what can be broken with all the here. Maybe this is bind gen. maybe this is... But this is Kling though. How did Google bring me here? Indeed, feature runtime fixes all problems. What the heck? Yeah, maybe this is binding generation between Rust and Cargo or something. Another test we could do, I wonder how much it will rebuild if LTO optimization But yeah, I would say, well, we are somewhat, let's see if this is smart enough to, sometimes it is, sometimes it isn't. But yeah, what can go wrong, does go wrong. I think we are somewhat 99% there, but yeah, there's always something. I mean, this is also a little bit frustrating if you see there, like car YouTubers or stuff, you can build on your vintage Porsche or something and have some progress, and here with IT you can spend like all your free time, or not free time, of your week and fiddle around with super complex infrastructure stuff, and at the end of the day, well, you are 99% there. But I mean, if you like worked a week on your vintage Porsche, then you have at least some dents removed and paint resprayed, and here it's like, yeah, still nothing to show, because yeah, when the breakage does it, maybe it does rebuild everything, maybe it doesn't. Also, isn't it nice that it's errors? Anyway, it's worth a try, I would say. This is also, I'm still thinking how to best build this channel and make this, because I mean, live streaming, building, run and build errors every day. Certainly also not so as amazing as it is. Some people tune in, but certainly not the most people's target audience. But yeah, this is what somewhat working in software looks for the, at least on some software, for some of the parts. If you have tips for this build error, for building this YouTube channel, leave them in the comments below, or other tips and tricks and hints and stuff. We can have this continue. Okay, this is Power PC, right? Oh, wait a second, did we? So this is just like native. We don't really like cross-compile. I wonder, by the way, can we rustc desk if this is also not vi, whatever iv is. This is not in there. Okay. Yes, theoretically it would be interesting that you install the ISO and have the Rust compiler there, but right now also not the topmost priority for these days. I'm already happy when we have the next ISOs out with Firefox. Of Rust, let's see, log, and let's touch Cargo while at it. On PowerPC 64 we still have all the Xorg, all the Mesa, all that stuff to finish. And yeah, that's probably it for this live stream. Makes no sense to overly extend this and watching this to build. I hope you learned something and enjoyed this, and don't forget to recommend this channel to your friends, family, subscribe, and hope you learned something, and to see you for all the next videos, live streams, and fun stuff to come.